Hello, my science homies, and welcome back. This is the last subunit. So this will be the last thing that you're going to learn about in Earth Science A, and I hope you learned a lot. All right, so the objectives for groundwater are going to be to describe the location and importance of the water table, to assess the consequences of overuse and contamination of groundwater, and to explain how human use of groundwater has changed over time. So, what is groundwater? As we know from the last subunit, groundwater is underground water found in spaces or pores in the ground. So they move and are stored in things called aquifers. We call them aquifers if we have a lot of water underground. And this is not an underground lake. This is going to be a quiz question. It is not an underground lake. You can't just go swimming in groundwater. It's little teeny pores between spaces in soil. So it's not like they're connecting or anything. It's just basically saturated soil. So like really, really wet, like dirt, basically. So groundwater is stored in these aquifers, and these aquifers have permeable layers of soil, sand, and rock. And if you remember, the word permeable means that something can go through it. So usually permeable things have pores in them so that like water can trickle down. So here is just a really, really simple water table for you. We've got water coming in, and then it goes down through some soil, and then all that unconfined water just kind of like moves around in the ground and is usually like either recharging a stream or taking water from a stream. So in this scenario, it's recharging a stream because that water is coming down from a higher elevation and going into a stream at lower elevation. So that stream is getting water from this aquifer. But then we've got a layer of some sort of like sand or something. It's low hydraulic conductivity confining unit. So that's just a really, really complicated way of saying water can't really go through this layer all that well. So that's how we get this confined aquifer down here. We have a layer where water can go down slowly, basically, through this layer right here, and it goes up very slowly as well. So then we've got the bedrock under here. This gray layer is bedrock, so water can't permeate through that at all. There's no conductivity, so no water is going through this permeable layer. So it's basically just stuck right through here. And this thing right here is what's kind of controlling the aquifer's water. So this little layer here that lets a little bit of water out and a little bit of water in kind of regulates this whole aquifer here. So here's another aquifer. We've got this clay or sand or whatever it is. That's that layer where it lets a little bit of water up, and then it lets a little bit of water down, and then is contained by bedrock. And then this unconfined aquifer, this is basically just a lot of soil that's really, really saturated with water, which means it's got so much water in it that it's basically leaking. And then it's going to be recharged by this lake, and this lake is actually also recharged by this river. So we've got a nice little cycle here. Okay, right here is the Ogallala Aquifer. This is the biggest aquifer in the United States, and it supplies water to, I think, 1/4 of the nation. So around 25% of the population of America is supplied by this aquifer right here. So what we see here is just like levels of the groundwater table and how it's moved over the years. So in these areas of dark red, the water table has declined over 200 feet, that's extraordinary. That's an amazing amount of water to be able to take out of an aquifer. So right here is they've taken way too much water out of there. And then 130 to 200 feet, that's still way too much. So right here, we've got a lot of pumping happening right here, here, here. And you notice this is an agricultural area. Right here is an agricultural area. And then this is just Texas. They have a lot of people, and it's really hot. So they take way too much. Then you go up into Nebraska. This is an agricultural area as well, but they've seen a rise in about 10 or more feet of water. So what's happening there? Well, they have less people, and they're going towards better farming practices as well. So we're becoming smarter with the way that we use our water. But the problem is that Colorado is supplied by the Ogallala Aquifer, And as you see right here, this is going to be the main supply that we take from. So right here, we're not going to be able to take any because we've already declined it about 200 feet. So we're gonna really start running out of resources. In this water, it all goes left. So California is the one that they're the state at the end there that gets the last remnants of water. So they're going to be the ones that feel more of the brunt of our water shortage as this continues on. So what is the water table? I talked about it a bit before in the Ogallala Aquifer picture. The water table is basically just like where the water is underground. And so we have this saturation zone. I've already talked about saturation, and that's basically just like really, really wet stuff. Basically, it's leaking. So the saturation zone, that's where all of the water is. That's where the soil is saturated, where you can get water from the soil, basically. So the water table begins at the top of the saturation zone because it wouldn't make sense to have a water table where there's no water. So it rises and falls, though. The water table rises and falls, and that's based on seasons and pumping and other things like animals drinking it, humans drinking it, that type of stuff. So, in the dry season, you're going to expect a lot less water in the water table. In the wet season, you're going to expect it to rise. If you put 15 wells in a water table, they're going to suck that water out of the water table, and it's going to lower. Then you're going to need to make deeper wells. And so that's what's happening here, basically, is there's so many wells in here that the water table is actually decreased about 200 feet. So what they do is they just keep making deeper and deeper wells, and so they're really just taking all of the fresh water out of that system. Okay, so groundwater. It's around 30% of all fresh water. It's a natural storage system. So basically, it's a long-term reservoir. If you know anything about a reservoir, it's a man-made structure where we hold water, basically. It's used for like hydroelectric power with dams and stuff like that. But groundwater is basically just a natural reservoir. So it's a wonderful thing that the earth gives us that we are kind of taking too much out of at this point in time. So we have this thing called recharge and discharge. Basically, recharge is replenishment of water into a system. So that's going to be like rain, snow melt, other things, other precipitation. Anything that adds water into like a river, basically, or an aquifer is going to be recharge. And then discharge is when you're just taking water out. So humans pumping, evaporation, animals taking water out, plants taking water out, and then transpiring that into the atmosphere. That's all discharge. So recharge is replenishing water in an area, and discharge is taking water out of that water table or that aquifer. So shortages are going to occur when water is used faster than it is naturally replenished. So if you discharge more from a system than you recharge from a system, which only happens naturally, we don't really ever recharge systems as humans, or if it's polluted by human activities, so you get dead zones, that's when you get shortages of fresh water. So pollution's really, really bad. Not only does it hurt our environment, but it hurts our available water supply. And then just taking too much water out is also really bad because it screws up the future for the rest of the people in that area. So why is groundwater important? Well, you should probably already know that, but it's really important for irrigation and drinking. And around 50% of the U.S. uses groundwater for drinking water. This is a quiz question. 50% of the U.S. uses groundwater for drinking water. That's a lot. That is an amazing amount of groundwater being used by us. And then overdraft has been lowering the water table for years. Like we're having a really, really big problem, especially in California and Arizona right now with overdraft. And we'll go back to the Ogallala Aquifer in California, and I'll just give you some examples. Here, again, this is overdraft right here. Any part where you're not getting more water into the system is overdraft. Like there's way more yellow and red and orange than there is blue. That's a really, really bad sign because, again, this supplies around 25% of the U.S. population with water. So, if we run out of this, what's going to happen? We're either going to start fighting or we're going to start dying. So that's something that we really need to think about for the future. And then here is the Colorado River. So the Colorado River supplies a lot of water to not only Colorado, but also Utah, Arizona, a little bit of New Mexico, Nevada, and then California. So they take a lot of this water and send it to Los Angeles. So a lot of the reason why they're having water shortages in California is because they have to wait for all of these people to take water out of this system before they can start taking water out of that system. So essentially, all those people in Texas that have taken all of the water out of the Ogallala Aquifer are not thinking about any of these people in any of these states. So those are some things that we need to think about, like maybe government restrictions or regulations, because there's no reason for California to have to be bearing that whole load when it's really not even 100% their fault. It's a conjunction of all of these people taking out way too much water for a long period of time. It's not just California. They're just feeling the brunt of that water shortage more than anybody else because they're the last people to get that water. So that's something to think about in the future. Maybe be more considerate about how much water you use, and just be more considerate about resources in general, because we need to be able to create a future for future generations. And if we get rid of all the water, then they're not going to have much of a future. Okay, so that concludes the whole class. So if you have any questions, comments, or concerns, like always, feel free to text, call, Schoology, pretty much whatever way you can reach me. Otherwise, have a wonderful rest of the quarter.